So let's work with this example. We got the lever A, B, and C that's loaded as shown. We got a couple of forces of 20 newtons with a 3 degrees inclination about the horizontal boat, and they got different senses, so they can work as a couple. Let's determine the moment of the force. One approach can be to find the perpendicular distance between these two. That distance will actually look kind of like this, perpendicular to both, or perpendicular between the action lines, not necessarily between the forces. I'm going to get on to stick with this one so I can show something that we're going to do. Now, this can be hard from the beginning. However, we can use some other tools to find this distance. For example, we can calculate the distance that we can or that we actually get information about. That would be the distance between A and C. The distance between A and C is going to be this one right here. This one right here. So this distance will be composed by or can compose the following rectangle triangle. Something like that. Something like that. That rectangle triangle will have that rectangle triangle will have this distance, will have this distance. The first distance, the vertical one, will be composed of the distance from A to C vertical. That means all this. That includes 3 and 6 meters. That means here we got 9 meters. The other significant distance is going to be the one that goes from A to C, but horizontal. That will include 5, 2, and 6. 5 plus 6 is going to be 11 plus 2, 13 meters. If we got 13 meters there, we can find two things. We can find the magnitude of the hypotenusa, that is the distance from A to C, and we can find this angle, the angle theta. That angle theta is going to describe the distance that we actually want. This one right here. Here it's going to be my angle theta. So let's go and find both parameters. First, h. The hypotenusa is going to be the square root of 9 squared plus 13 squared, which is going to be equal to 15.81 meters. And we can obtain theta by the tangent. We know that tangent of theta should be 9 over 13. That means theta is going to be equal to the inverse tangent of 9 over 13. Theta is going to be what? Well, where is that value right there? 34.69. 34.69 degrees. With that thing in mind, we can start to build up what is going to be my distance perpendicular D. If you notice, we kind of form another rectangle triangle with the hypotenusa we already know and this distance. And not only that, we can get what's the value of this angle. By similarities, this angle right here is going to be composed by 30 degrees, which is this one right there, plus this angle right here. I know 3 degrees correspond to this part too. That means that this section right here is going to be also theta. So let's build up that triangle and try to manipulate. That didn't work well. Let's try again. Good enough. We know that this triangle will have 30 degrees plus theta. We know this h is going to be the same as for this other triangle. That means the combination of this h and this angle can give me this distance. The distance that's going to be the one distance perpendicular to both forces. Let's find out what's going to be this angle. So this angle that I'm going to call alpha, it's going to be 30 degrees plus theta. Alpha is going to be equal to 30 degrees plus 34.69 degrees. We're going to have 64.69 degrees as my angle alpha, which is going to be right in here. If that's my angle alpha, and if I already know h is going to be worth 15.81, we can obtain this component using the cosine of alpha, and we can obtain this component, which is the one I care, using the sine of alpha. So let's look for this d. We know sine of alpha is going to be equal to the opposite side divided by the hypotenusa. That means d over h. If we're looking for d, we just solve for it. That means d is going to be equal to h sine of alpha. That means we're going to go d equals 15.81, which is h, times sine of 64.69 degrees, which is hypotenusa. The distance, the total distance, the total perpendicular distance between my two forces is going to be let me just fix this up. That's going to be 14.292 meters. Having to know that and remembering that the moment of a couple is going to be equal that distance times the force, moment of the couple is going to be equal to 14.292 times 20. That means the moment of that couple, 14.292 times 20, is going to be equal to 285.84 newtons meters. And that's going to be the result for the problem.